Dear students, welcome to the first lecture for the Pure Mathematics course. We will start with Chapter 0, which is the review for the algebra, and this is the basics for the mathematics techniques. This chapter objective is to be familiar with the sets, real numbers line. Also, we will introduce the related properties for the real numbers in terms of their operations. Then we will review for the procedures for rationalizing and take their radicals. Finally, we will perform operations for algebraic expression. This chapter is partitioned into 6 subsections. The first one is the sets of real numbers, then some properties for the real number. Section 3 is the exponents and radicals. Section 4 is the operations of the algebraic expressions. Section 5 is factoring polynomials, and finally, Section 6 is the fractions. Let's start with the first section, which is the sets of real numbers. First of all, we should know what is meant by set. Set is the collection of objects, and an object in the set is called an element. Of what is it? There's different types of integers, like positive integers or a set of positive integers which begin with 1, 2, 3 up to positive infinity, and set of negative integers which is -1, -2, -3 up to negative infinity. And the real number is shown here in this graph, which is the real number for positive direction here in the right hand side, and negative side is the negative direction. Here 0, which is origin point. We have here very important definitions. The first definition we have is the natural numbers. The natural numbers is any set that's in this the members are 1, 2, 3 up to positive infinity, where 0 not included. Then we move to the definition for the real numbers. The real number is a set of rational and irrational numbers. I mean that all rational and all irrational numbers are included in the real numbers. So we ought to differentiate between rational numbers and irrational numbers. Rational numbers, that the numbers can be written as the quotients, which is numerator and denominator, which is fractions, like p over q, 2 over 3, where all the time the denominator is not equal to 0. Irrational numbers is number that can be written as a fractions. Any number can be written as a fraction is called irrational, which is the opposite for the rational number. So let's move to another important definition, which is the integer. Integer is a number in the set from negative infinity, -3, -2, -1, 0, and 1, 2, 3 up to positive infinity. All these numbers in the set is called integer. So we can conclude these sentences from the previous definitions. Every integer is a rational number, of course, because the integers in the set from negative infinity to positive infinity. Every rational number is a real number, of course, yes, because real number included rational and irrational numbers. Rational numbers consist of all decimal numbers, yes, of course, because we can write any number that on the fraction. In the case of rational number, for example, 2, 1 over 2, we can write it in as a decimal number 0.5, or 3 over 2, we can write it as 1.5. So we can say that the rational number is a decimal number. move to the second section, which is some properties for the real numbers. The properties for a real number is very important, and you should know what is the terminology for or mathematical terminology for each one. We start with the transitive property, which is if we have A equal P and P equals C, then A equals C. The second property, which is closure property of the addition and multiplication, which means that any two numbers can be added or multiplied and the result is two numbers, or the real number. If we have two numbers, we can add them or multiply them by each other and the result will be a real number. The property number 3, which is the commutative property. The commutative property for addition and multiplication, which means A plus P equal to P plus A, and A times P equal to P times A. To the fourth property, which is the associative property for addition and multiplication. If we have A and then add two real numbers added to each other, we can say that it's equal to A plus B and the results results will be added to the C, which is a real number, and the right hand side in this case equal to the left hand side. The same for multiplication, which is A times B and C equal to AP times C. Then property number 5, which is the identity property. The identity property says that if we add any real number or any integers to a 0, we will take the result is the same number. And in the case, the same for multiplication, but if we multiply it by 1. If you multiply any number by 1, the result will be the same number. Property number 6, which is inverse property. Inverse property means that we can add negative A to A and result will be 0. And the reciprocal property, we can multiply A by A to the power negative 1 and the result will be 1. Property number 8, which is the descriptive property. The descriptive property means that we can distribute the A, which is the sample or a number, to two real numbers or two samples or a sample and real numbers added to each other and get the results as shown here. A times P, which is AP, and A times C, which is AC. And the same for the multiplication. If we have P plus C multiplied by A, so we can multiply A plus P plus A plus C plus A, C plus A. This is A. Now let's apply some properties for real numbers with these examples. If we have this ax multiplied by y minus 3z plus 2w, the equivalent to if we have y minus 3z plus 2w multiplied by x, and the same if we have an inverse. Example 3 shows that if we apply the property of the real number, we can prove that AP over C is equal to A times B over C, and of course C not equal to 0. This can be shown by AP over C, take AP alone and multiply it by 1 over C, then take A multiplied by P over C, if we multiply P here, so equal to A times B over C, which is the right hand side. So the left hand side equal to the right hand side here. To another example, show that A plus P over C equal to A plus C plus P over C. let's take the left-hand side and make our steps to the result of the right-hand side. A over A plus B over C equal to A plus B times 1 over C, which is equal by descriptive probability A times 1 over C, A over C, plus B times 1 over C, B over C. So by taking C common factor, C equal to A plus B over C. Now move to the third section in this chapter, which is exponent and radicals. Here you may be familiar with the exponent and radicals in other topics, but we have here some rules for the exponent first. The exponent x to the power n here called the exponent, where x is the base and n of here this power is called exponent. The first properties for the exponent that x to the power n equal to multiplying x by itself n times. So x times x times x n times equal to x to the power n. How we get this value? By adding the 1 here to 1, 1, 1. So if the bases are the same, we can add the power or the exponent. So this is the result that x to the power n equal to x multiplied by itself n times. This is for the first property. Second property, which is x to the power negative n equal to 1 over n. We can convert the negative exponent here to a positive one by say that x to the power negative 3, for example, equal to 1 over x to the power 3. Also, we can get rid of the negative exponent in the denominator if we have 1 over x to the power negative n, which is equal to x to the power positive n. Finally, the most important rule in the exponent also, which is x to the power 0 equal to 1. Any number to the power 0 equal to 1. 11 or negative number all to the power 0 equal to 1. 3xy to the power negative 1 all to the power 0 equal to 1. Any number can to the power 0 equal to 1. Let's take or show you here the examples for these four properties, which is 1 over half all to the power 4. This means that we multiply 1 over half to 4 times by itself. And per p, 3 to the power negative 5, we can convert it into a positive exponent by 1 over 3 to the power 3 to the power 5. Also, 1 over 3 to the power negative 5 equal to 3 to the power 5. And finally, 2 to the power 0 equal to 1. Here we have more and more examples and rules for the radicals and exponents. Of course, we already introduced these four here in the previous slides, and we now will move to the rule number 5, which is if we have the same base x and x, we can subtract the power. So if we have 3 to the power 5 over 3 to the power 2, the value is equal to 3 to the power 3, which is 5 minus 2 here. Number 6, if we have the same value in the numerator and denominator, we of course it's equal to 1. In rule 7, here it's very important, take care, because if we have an base x or any number or any sample and we have it to the power, say, let's say to the power 2 and all to the power 5, the result is multiplying the two exponents or two power by themselves. That will equal to x to the power 10. So here x to the power m all to the power n is equal to x to the power m plus m times n. It's very important. The number 8, where here, which is x times y all to the power n, we can use the descriptive property for distribute the n power to x and y, because we have two different bases. So will be x to the power n times y to the power n. The same for the fraction, we can distribute the n and the power to x and y. So x over y all to the power n is equal to x to the power n over y to the power n. And here it's very simple property, and we will use many examples and exercises, so pay attention. X over y all to the power negative n, negative in the power. So we want to get rid of the negative exponent by here, make it y over x all to the power positive n. The numerator will be denominator and numerator will be denominator. So just make the fraction in the opposite way, and the power will be positive. For this here, for this point or this rule number 10, we got all the related rules by the exponents. Now we will move to the rules for radicals and how can we deal with them. Number 11, if we have x to the power 1 over n, this means we can convert it to the radical sign. So we will 1 over x to the power 1 over n equal to the nth root for x. The nth root, this means root x with index n. Number 12, if we have a negative exponent and we want to get rid of it, we will convert it to a positive one by using 1 over x to the power 1 over n and then convert the exponent to our radical sign. Number 13, if we have two different bases and we have common index, n is index, this means this is index and this is index, and we have the same index but we have different bases, so we can multiply by each other and take this index as a common factor. Take care, we don't multiply the index by each other, we just take it as a common factor. So the result will be the root for x and y with index n. The same if we have a fraction. If we have two different bases, x and y, and have the same index n, we can take common index n and x over y. Number 15, if we have the same index, the same base, but we have different index. We have different index here like this. N and n, n and n. Root n, and with the base is x. We, in this case, multiply m times n and will feed the value. Say if we have root 3, root 4 with x, so it will be root 12 roots for x. This is by multiplying the two index by each other. Number 16, x to the power m over n, which is have here an exponent, and we can convert it to a radical sign. So we can say that x with power m with take the radical with an index n. So the value will be here. Finally, the final rule for the radicals, which is very important and can simplify many exercises for us, and we can use it in many solutions, which is if we have a radical index with the same power, we can lead it with each other and the base is here equal. For example, if we have the index 9 and y to the power 9, say here, let's erase all this and right here. If we have a 9th root with y to the power 9, so this is will here eliminate with each other and the value will be y. Take care from this rule, it's very important. Now let's move to one example for the exponents. Here, the head of the question is eliminate the negative exponents. If we have x to the power negative 1 plus y to the power negative 1 and then simplify. X to the power negative 1 equal to 1 over x plus y to the power negative 1 equal to 1 over y. If we have y here, we take a common factor, so the value will be y plus x over x plus over x times y. Here we get rid of the negative exponent at the question's requirements. Number B, simplify x to the power 3 over 2 minus x to the power 1 over 2. Now we will use the descriptive rule to take a common factor here, x to the power 1 over 2. We take the least value in the power. The least value, please concentrate, the least value. We have 3 over 2 and 1 over 2, so we will take the smallest value, which is x to the power 1 over 2. And the rest is equal to x minus 1. Here we have two terms, first term and second term. From the first term, we take x, the rest is x, and from the second term, the rest is 1. Number C, eliminate negative exponents in 7 to the power 7x to the power negative 2 plus 7x all to the power negative 2. Take care, please. This example is very important that may be different from one to another. To eliminate the negative exponents here, we put the negative sign, our negative exponent, on in the denominator as follows: 7 over x to the power 2 and plus sign here, and then 7x to the power negative 2 will be 1 over 7x all to the power 2. And we can simplify then by 7 over x squared plus 1. Here we can distribute to the two values. 7 to the power 2 equals 49 and x squared. Let's move to another example which eliminates the negative exponents. Here we have negative exponents inside the brackets and here all to the power negative 2. Let's take it step by step. If we have x to the power negative 1 will be 1 over x and negative sign for the question, then y to the power negative 1 equal to 1 over y, all to the power negative 2. And this we can't make the denominator and the opposite till we first take a common factor in the denominator as follows: y here x times y, xy, and in the denominator will be y minus x. Till now we don't eliminate the negative exponent negative 2. We just take common factor in the denominator. Then we will get it here, y minus x over xy will be equal xy over y minus x, and the negative exponent will be positive. Then we will use this descriptive property for distribute 2 here, so the result will be x to the power 2, y to the power 2, over y minus x all to the power 2. Number C applies the descriptive rule to this value. It's very simple, just we will applying this rule. X times y, x to the power 2 over 5 times y over times 1 over 2 will be x just no same bases. The bases differ. We can do anything more. But here, if you multiply x to the power 2 over 5 times 2x to the power 6 over 5, now we have the same base, x and x. So we should add the power. The result will be 2 to the power 8 over 5, which is 2 plus 6. 2 over 5 plus 6 over 5 equal to 8 over 5. Example number 10, we will introduce the examples for radicals. Here, just simplify this value. Remember the radical rules and properties and simplify the values. To simplify this value, we just partitionate this radical sign into 3 parts. The first part will be x to the power 2 all to the power 3 and radical with index 3. And here times root y to the power 3 with radical in third with index 3. And finally, the final one, which is the third root for y. Now we can eliminate the power with the radical sign to get x squared, the power 3 with the radical sign to get y, and finally this value will remain the same, third root for y. Here, simplify root 2 over 7. We can distribute the root 4, which have the same base and different base, but it is same index. So we have 2 over 7 times 7 over 7. From where we get the 7, this is just to simplify the denominator here. So multiplying by the same one because it is a square root, so we can say that root 14 over root 7. And the other radical example here by numbers. How to simplify the value root 250 minus root 50 plus 15 root 2. This is by partitionated this value 250 root 5 times root 10. How to get this? This is by saying that root 250 equal to root 25 times 10. And if we partitionate the root, this will be 5 times root 10 because root 25, the second root for 25 is equal to 5 and this is root 10. This is for the first term. Then let's move to the second term. It is the same idea because we can say that root 50 equal to root 25 times 2. So root 25 equal to 5 and the root 2 remains the same. This is for the second term. And finally, the root 15 root 2 will be the same and we can add it anymore. Here we have two roots that have the same value. 5 root 2 plus 15 root 2 and this will be 10 root 2. This was for this section till now, and in the second video we will continue chapter 0. Thank you for listening.